This is a quick video over the total probability rule. So let's say we have a Venn diagram, and inside our Venn diagram we have R. So we have some event R, and on the outside we have some event B. So we have event R and event B. Event B. Now let's say we have some event that crosses into R and B, and we'll call that C. So event C. Now we're going to assume that R and B are mutually exclusive. So that means you can only have an R event or a B event. Now that doesn't mean C is mutually exclusive, because right here R and C can occur, and right here B and C can occur. Now the total probability rule is relatively simple. It says the probability of event C occurring if R and B are mutually exclusive is equal to the probability of the intersection of event C, event R, plus the probability of event C intersection B. So all it's saying is this area plus this area will give you the probability of C. Now if we remember from the given function that the probability of event 1 intersection event 2 is equal to the probability of event 1 given that event 2 has occurred times the probability of event 2. So if we remember that, then we can rearrange this as the probability of C given that R has occurred times the probability of R plus the probability of C given that B has occurred times the probability of B. And notice all that means, all this part really means right here is this area divided by the total area. And all this means is this area divided by the total area, and I mean total area. So now let's test that. Let's say we get one card out, and we'll say R stands for red. You probably already knew that, and B stood for black. I'm assuming you already guessed that I was going there since this deck of cards was right there. And C is getting a king. So what this statement says is the probability of getting a king is equal to the probability of getting a king given that we got a red card. So instead of writing out that, what's the probability of getting a king given that we got a red card? Well, there are 2 red kings out of the 26 red cards. So we know we had a red card. This statement is saying that we got a red card. And it's just asking what's the probability of it being a king. Now we multiply that by the probability of getting a red card. Well, there are 26 red cards out of 52 cards. Now we add the probability of getting a king given that it was a black card. So there are 26 black cards, and only 2 of those are kings. And we multiply that by the probability of getting a black card. There are 26 black cards out of a deck of 52. Notice that 26 cancels there, that cancels there. So that becomes 2 out of 52 plus 2 out of 52, or just simply 4 out of 52. So the probability of getting a king is 4 out of 52. And I mean, I just did this to a relatively simple case. We can actually change that up a little bit by adding in maybe another event. And I don't know what this event would be for a deck of cards, but let's say we had some other event D, and it was also mutually exclusive, event D. So all these right here except for C are mutually exclusive. And if you don't remember what mutually exclusive means, that means you cannot have event R occur and event D occur at the same time. Or you cannot have event B occur. So let's just, for the safety, this is event D. This is the area for event R. event R, and this is the area for a black card. This area. That area. So all mutually exclusive means is you cannot get a red card and a black card at the same time. And note, C is not mutually exclusive relative to D, R, or B. Because you can get C and R at the same time, you can get B, B and C at the same time, and you can get D and C at the same time. So it's only R, B, and D relative to each other that are mutually exclusive. So let's just add in this real quick. So the probability of event C occurring is now the probability of event C intersection R plus event C intersection B plus event C intersection D. And that's just written on as the probability of event C given that D has occurred times the probability of D. Probability of D. And I mean, this can go on forever. You can just keep breaking it up into smaller and smaller pieces as long as they are mutually, it's really important. You have to really remember that they must be mutually exclusive or this does not work. They must be mutually exclusive events.